Namaskar friends, I welcome you all in this class of mathematics. So today we are going to start a new topic on limits. It's in the calculus, so very fundamental. We will discuss how limits are taken, and as we proceed you will come to know the importance of limits in the function, and then further in subsequent lessons we will also learn that how we use limits in calculus. So calculus is a very potent tool in which limits has a very important role. So today we will start with the concept of limits. So we are going to learn within the limits direct substitution method. It is very simple. The method is quite simple, but the concept is quite useful. So suppose there is a function y is equal to fx, where fx belongs to subset of R. Fx is an element of R. R set of real numbers. So suppose we take fx is equal to 3x plus 2. Now for giving concept of limit, we will give an example. Say we are making a table, okay? So let us take the value of x 1.9, 1.98, 1.998, 1.998, and so on. What we are doing, we are taking the value of x nearer to 2 but lower than 2. And so on. So these are the value of x. Now what will be value of fx? Fx is equal to 3x plus 2. So quite simple, you can calculate. It is 7.7. Next is 7.94. I mean, when x is equal to 1.98, then fx will be 7.94. 7.994. You can check it. 7.994 and so on. This will be equal to 7.1234567 4 and go on. So you can see that as the value of x is going nearer to 2, 1.98 is more nearer to 2 than 1.9, then 1.998 is still more nearer to 2 than 1.98, then further so on. So as we are increasing the value of x and making it nearer to x but smaller than 2, the value of fx is also increasing in the similar manner from 7.7 to 7.94 to 7.994, then 7.994 and then 7 so on. So this is going to nearer and nearer to 8. Now we are approaching, we say that we are approaching, as x is approaching 2 from the left side. So left side, that you remember the real number line. So let us take from the right side. Left side means less than 2. Now we approach from the right side, that is x greater than 2. So x, value of x, say 2.1, then 2.01, 2.001, 2.001 and so on, 2.701. And then we can go on increasing. Then what will be the value of fx, that is y? It will be equal to, you can calculate, 8.3, 8.03, 8.003, 8.003 and then so on, 8.703 and it will go on. So you can see see, this is a number line and x. So as x, we are approaching it from the left, I mean 1.9, then 1.98, then 1.998, and so on. This side, the value of y is approaching on the number line, say this is y. So this is y, fx. So its value 8 is here. So as we are going nearer to x, nearer to 2, x is going, this is becoming nearer to 8. And again from the right side, as the value of x is approaching nearer to 2, the value of y is approaching nearer to 8. So we say that we write it like this, that as x approaches to or tends to 2 from left side to minus, y approaches 8. And if both are equal, then we write limit of function fx as x approaches 2 from left side minus is equal to 8. And again limit when x approaches 2 from the right side, then also the value of x approaches to 8. So either from right hand side or left hand side, we can find this value by direct substitution method. What is direct substitution method? As the name suggests, suppose x tends to a constant, then limit of fx will be equal to fa. So as the name suggests, we directly substitute the value of at the place of x, we substitute the value of a. So fa will be its limit. So this is called direct substitution method. It's very simple. Now there are some rules which are quite obvious rules. So you will have no difficulty. In fact, you don't need to mention it every time or remember it. You can see suppose limit x tends to a, fx plus gx. If fx and gx are real valued function. Real valued function means that fx and gx are, it means that fx and gx are element of R, the set of real numbers. So this will be equal to limit x tends to a fx plus limit x tends to a gx. It may seem trivial to you, but this is important, and there is proof which we are not going into this because this is not in your course. So, but this is quite simple, and you can use it anytime. Now the second, limit x tends to a fx minus gx. So this will be equal to limit x tends to a fx minus limit x tends to a gx. Limit is a concept, is you can say operator on the function f and g, and it's simply saying that either plus or minus, if this is a composite function plus and minus, so if you take limit, so that you can take separately limit and then minus it. So it will be used, this concept will be used, because sometimes it is not easy to calculate fx minus gx, or it is not defined, but you take the limit of different function and then you can subtract or add. Then similarly, it is also true for multiplication. Limit x tends to a fx into gx, so its value will be, you take separately limit of x tends to a fx and limit of gx x tends to a, and then you can multiply. Again For division also, fx upon gx will be equal to limit x tends to a fx divided by limit x tends to a gx. Now if you take nth root, limit x tends to a nth root of fx, so it will be equal to it will be equal to that first you take limit x tends to a fx and then you can take its nth root. Now suppose function is there in the denominator, then this will be equal to 1 divided by limit x tends to a gx. Again for logarithmic function, suppose limit x tends to a log of fx. In that case it will be equal to that first you take limit and then you can find out the log. Limit x tends to a fx what will happen in the case of exponential function? Limit x tends to a So in the case of exponential function, suppose e to the power fx, so this will be equal to first you take the limit of the function fx, and then you take its exponent. Suppose limit fx to the power gx is there. Two functions. So this will be equal to limit x tends to a fx. Separately we will take limit, and then limit x tends to a gx. Suppose there is a multiplication by a constant k. So k will come outside, and then we can take limit if k is constant. In the case of a constant, simply constant, its value will be equal to k because it's not changing, so it is not dependent on x. It will remain same. It is constant. Okay, so these are very simple rules, and you should take care of that, because often in solving the problem such in the functions you will have to do such operations while taking limit. So let us take an example. Limit x tends to -1, and the function is 1 plus x square up to x to the power 100. See? So by direct substitution method we will call it DSM. Let us see its solution. We will use direct solution, so its value will be, in the place of x we will put -1, so 1 plus -1 to the power 1 plus -1 to the power 2 plus -1 to the power 3, and so on. We will go to the -1 to the power 100. So as you know, the even power, this will become +1, -2, -4, and for odd powers it will be -1. So it will be equal to 1 plus 50 times, because it goes to 100 power. So from 1 to 100 there will be 50 odd numbers. So 50 times minus 1 will be repeated, plus 50 times plus 1 will be repeated. So this will be equal to 1 plus 50, 1 minus 50, because 50 times minus 1 and then 50 times plus 1, so it will be plus 50. So these will be cancelled out, it will become 1. So its limit, the limit of this function will be equal to 1. Now let us take another example. Limit x tends to root 2 x square plus 3 divided by 3 minus x4. So we will use direct substitution method. It will be equal to root 2 square plus 3 divided by 3 minus root 2 to the power 4. So this will be equal to 2 root 2. Root 2 square will be equal to 2 plus 3 divided by 3 minus root to the power 4. So root 2 square will be 2 and 2 square will be 2 square will be 4, 3 minus 4. So it will be 5 divided by minus 1. So is equal to minus 5. Okay. Now let us take one more example. So suppose function is given like this: fx is equal to 2 minus x square when x is not equal to 0 and it is equal to 2 when x is equal to 0. So what will be the limit of x when x tends to 2, we have to find out. Now how will we proceed? Because there are two values. If x is not equal to 0, then the value of fx is 2 minus x square. If x is equal to 0, then value of fx is equal to 2. So here limit x tends to 2, fx will be equal to 2 minus x square. Why? Because x is not equal to 0, x tends to 2. So either it is approaching from left or right. It's not equal to 2, it's near to 2. So we will take 2 minus x square. You see? This is the number line 2. So x is approaching either from this side or this side, but it is not equal to 2, it is near to 2. So we will take this function, the value of function will be 2 minus x square. So this will be equal to 2 minus 2 square. Now the value of x, of course, it will be equal to minus 2. But suppose in the same question, if we have to find out limit when x tends to 0, because the question is the value of x is 0 or x is not equal to 0. It's not the 2, it's 0. So there is error here, so let us correct it. Okay, let us correct it. So we have to find out this one. Okay, so let us rub it off. We will do it again. Since the value of the function is defined like this, that either x is 0, then its value is 2, and if x is not equal to 0, its value is 2 minus x square. So it's the value of 0, either approaching from this side or this side. We have to take limit when x approaches 0. So in this case, limit when x tends to 0, fx, it will be equal to 2 minus x square. Because it is not equal to 0, it is near to 0, either from this side or this side. So its value will be equal to 2. Now let us take few more examples quickly. Limit x tends to 2, x square minus 2x plus 3 to the power x square plus 1. So this will be equal to, because as we have stated the rule earlier, it will be limit x tend to fx and gx. So we will take it separately, x square minus 2x plus 3, and then its power will be taken separately, its limit x tends to 2, x square plus 1. So now this will be equal to here we will put 2 in place of x, so 4 minus 4 plus 3 to the power 4 plus 1. So this will be equal to, these will be cancelled out, so 3 to the power 5. Okay, which is equal to 243. One more example we can take. Limit x tends to 1 log of x4 plus x square plus 1. So as we have seen earlier, that its limit will be first take limit of the function and then its log. Okay, so we will put 1 in place of x, so it will be log of 1 plus 1 plus 1, which will be equal to log 3. Now what happens when the direct substitution method fails? Failure of direct substitution method. In what cases? There are cases where the direct substitution method fails. So these cases are: number 1, when two functions are there and when you are substituting it comes in the form of 0 upon 0. Now the second case may be that is coming infinity upon infinity. Third case may be it is coming out 0 into infinity. Fourth case may be that it is coming out to be infinity minus infinity. Fifth case may be it is coming out 0 to the power 0, and sixth case may be 1 to the power infinity, and seventh case may be infinity to the power 0. These are the 7 cases in which you can come across a situation where this direct substitution method will fail. So in that case, friends, in the next class we will see that how to solve such problems. There are many methods, and we will discuss about these methods in the next class, that when the direct substitution method fails, where fx and gx are in a fashion, they are either coming in the form of when we substituting x in place of x the value of a constant, then either it is coming in the form of 0 by 0 or infinity into 0 or 1 to the power 0 or infinity to the power 0. So there are 7 cases as I mentioned. In such cases the direct substitution method fails, so then we use other methods to solve such problems. We will discuss it in the next class. Thank you very much.